What do you know about slopes? How do you find slopes?
Rise over run.
Rise over run. Good. Rise over run. When you're talking about rise over run, what variables or in an ordered pair situation are the rise?
Y.
Correct. The y values are the y's, and then the runs by default are the x values. All right. So we've all done this before. We've worked with slopes. We've talked about slopes being, we use the letter M. I'll go into why they use the letter M here in a second. And we know it as rise over run. Earlier today in the other two classes, when we talked about rise over run, I put up a symbol, and everybody understood it. So I'm assuming you guys know this as well. What does that stand for? Delta. And what does it say? What does that mean? Change. Very good. Change. It's the Greek letter delta, and it stands for change. So it's the change in y values divided by the change in x values. This ratio allows you to figure out, like you said, the rise over run. When we're looking at these things, it is a set of ordered pairs. You have two sets of ordered pairs. First set of x and y values, and second set of x and y values. And then the generic formula for slope, which we all have done many, many times. Change in y sub 2 minus y sub 1, x sub 2 minus x sub 2. Now, when you have two sets of points, does it matter if you go from right to left or left to right for the ordered pairs? It doesn't really matter. The reason why I keep it the y sub 2 first instead of the y sub 1 first is that every formula that you see in an algebra or a geometry book, when you're talking about like distance formulas, Pythagorean theorem, things like that, it always does the second value first and then goes that direction. It works from right to left. It's just kind of a math etiquette way of doing it. So as you go through these things, this is not new. You guys already know that there are 4 types of slopes. Oh, I forgot. Slope. Where do they come up? The letter M. This always comes up. If you look at the word slope, why don't they use the letter S? Because it looks like a 5. Why don't you use the letter L? Same thing with the O then, because it looks like. All right, this is a little bit trickier. Why don't they use the letter P? Perimeter, or you ever done probability? Yeah. Probability, you see a lot of time, you'll see it if you take statistics at all, they use the letter P to find probability. And then E is an exponential function. So what they did is they just kind of went through the alphabet trying to figure out what letter could they use. What do they use A, B, and C for? Yeah, the Pythagorean theorem, right? A squared, B squared, C squared. So that's why they don't have A, B, or C. We just talked, what's next? A, B, C, D. D, what do you use D for? Distance. E, we just talked about. F, this is you don't know why they use F. Function. So F, G, H, those all use with functions. Letter I. Square root of -1. It's an imaginary number. Did you know that there's things called imaginary numbers? Numbers you could think about, but you can't speak of because it's a figment of your imagination. And then you just keep on going through the alphabets, and they left with the next letter that was available was
E. What about E?
I just talked about it.
Energy?
Exponential, e to the x. So they left with M. You don't believe me?
What about Z?
J, joint variation.
Isn't it M for Mercury?
No, the guy that discovered slope was, I think last name was Martin too. That's the one.
Oh, that's why Ben Martin.
No, Steve.
Oh.
I just made that entire story up, and you guys all believed it.
I didn't believe it.
That wasn't true.
Not even close.
What was the real
Then what was the point?
That was the letter.
Just to see if you guys would, how long you would believe me.
Oh,
I have no idea.
M for Mercury.
Sure, Steve Martin's legit. I got arrows coming through my head, exactly, yeah.
It seems legit though. It makes
It's
sense.
good, isn't it?
It makes sense.
I do that story every
Maybe,
year.
maybe that is the reason.
Sure, we'll believe it. Tell your parents that, they'll love it.
If you believe in something, it becomes slightly less fake.
Was it,
Right.
there's a fact about that. Anyway, 4 types of slopes. What are 4 types of slopes? Give me a type of slope.
4 types of slope.
Negative. All right, negative looks like what? Down and to the right? Okay.
What's that positive?
That's a negative slope. Then what's a positive slope?
Little positive.
All right.
Like this.
Vertical. All right, so if it's vertical, what's the slope of a vertical line?
No change.
0.
Oh, that's vertical.
If it's vertical, what's the slope of a vertical line?
Infinity.
No.
Infinity.
Now you're making up stuff. It doesn't work.
No, that's
All right, let's think about this. When you're looking at slope, if you're looking at slopes, is the change in y over the change in x? All right. Yes. Go ahead. Oh, sorry. If it's change in y over change in x, the slope of a vertical line, what isn't changing? X. So if x isn't changing, what's same thing minus same thing? 0. So that means that your denominator is 0. Can you have 0 in your denominator? No. So a vertical line has an undefined slope.
That's my word.
Uninfinite, yeah, they're very closely related. And then the last one is the horizontal. And horizontal has what for a slope? 0, very good.
Yeah.
0 for a horizontal slope because 0 is in the numerator. 0 can be in the numerator, and any number in the denominator is just going to give you 0. Another way to remember horizontal line being a 0 slope, what is the second letter of the word horizontal?
0.
No, it's close enough.
Are you 0?
Sure, I wouldn't know the difference. Okay. Like I said, you've all seen this before. This really isn't anything new. What's going to be a little bit different for us now, instead of just calculating plain old boring slopes all day long with just, sets of ordered pairs, what I'm going to do differently is I'm going to give you guys things like this, where I will give you the slope, I will give you one set of coordinates, and one of the x values and one of the y values. And you have to find that missing coordinate. All right. And if I'm not mistaken, Seth did some of this stuff with you guys last year. Yeah. You guys should have seen a little bit of this last year. So this is just one step ahead of where the normal classes would be. We're going to push into a little bit more of the algebra of it, try to make things a little bit more complex on you, just to make your brains hurt just a little bit more than normal. So remember, when you're dealing with trying to find the missing coordinate in a problem like this, you're given your slope, you're given a set of ordered pairs, and one of the other coordinates. The easiest way to get this stuff going is just to write the formula out so you know what to substitute in. And now it's just a matter of knowing that there are 5 total, variables here. There's 5 possible variables: slope, your 2 different y values, 2 different x values, and you happen to know 4 of them. So you just substitute in. Your slope is 1/10 equals y minus 2 over 14 minus 4. Now, there's 2 ways of going about this problem. This one happens to be a very, very simple one to solve for. The generic way of doing it is the following. Whenever you have fraction equal fraction, how do you solve that? Yeah, you cross multiply. So in this case here, if I have fraction equal fraction, I have, well, it's 1/10 is y minus 2 over 10. And I would get 10 times y minus 2 is 10 times 1. You agree?
Yeah.
Okay. In this case, it's even easier than that. These are both 10s in the denominators, right? You know that. So that means the numerators have to equal each other. What's y? 3. Yeah, and that's fine. That's absolutely fine. I wanted to set it up in a way that to show you that either way you go, if you want to go I wouldn't call it longer way, but if you do go that longer route of just fully doing all the cross multiplying, you will end up in the same solution. But not always is it going to be that clean. Sometimes it's going to be a little bit different setups where you will have to do a little bit of work. All right. For example, try that one. I have a slope of -1, an ordered pair at x, comma 4, and the other ordered pair is at -6 and 8. So what I'd like you to do is just take a minute and try and solve. Now, one of the things that students tend to do when they see this is they start out with the -1 is 8 minus 4 over -6 minus x. And what they forget to do is this. Over 1. Yeah, throw it over 1. Because now you know, now you have fraction equal fraction, so you can cross multiply through. It's a little bit easier to remember it that way when you have just an integer on the side. So you have -1 times -6 minus x is 4.
Oh, I didn't even cross
Yeah, it works. I mean, like I said, a lot of these things that I do this way, I try to go back to a generic method. And like, if you want to shortcut through, I have no problems with that at all. I like to just show a real baseline of it, and then you guys can go with it. All right. So from here, you just distribute out, and you're done. And yeah, there are multiple ways of setting it, but yeah, just set it up. Throw it over 1, and you won't have any issues.
Yeah, that's good help. Guys.
Every once in a while, we do okay, right?
Yeah, very well.
Also go along with slopes. I want to review with you real quick here. Small button. What does this symbol mean? Parallel slope versus perpendicular slope. So, if my original slope is 2/3, if my original slope is 2/3, what will its parallel slope be? It's 2/3. Very good. Remember, parallel lines have congruent or equal slopes. What would its perpendicular slope be?
Yeah, yeah.
It's the opposite reciprocal. So what is the parallel slope to a slope of 0? Parallel slope to a slope of 0.
Oh, that would be 0.
0.
But they just have different y intercepts.
Right. Then what would be the perpendicular slope to a slope of 0? Undefined.
Oh, yeah.
Remember, 0 slopes are all horizontal lines. All horizontal lines are perpendicular to vertical lines. All horizontal lines are parallel to horizontal lines.
That's important.
Usually, yes. Okay? If we didn't know that, we wouldn't be able to make graph paper. Or right angles.
Or your shirt.
Or my shirt.
Or your tie.
Yes, by my tie if I turn my tie sideways.
Or your belt.
You never know. This is going to be a long year.
Or you.
Yes, exactly. So now that takes us out of 2.2 already. Woohoo! We're cruising. And now we're going to use what we just did in 2.4. Now, what I want you guys not to worry so much about the section names and the titles and all that kind of stuff as we go through, especially these first couple of chapters, because a lot of this stuff is blended together of review. So I'm just trying to go back to some refresher and give you guys that little bit of a twist that we're going to use with it now. So we've already talked about slopes, we talked about parallel, we talked about perpendicular. Now, the next step in doing all that is to start writing equations. And this is something you guys have been doing for a very long time. You guys all have worked with this over and over and over again. What's slope-intercept form? What does that look like? Y equals mx plus b. Why do you think that slope-intercept form is important? Okay, which axis?
The one.
The y, all right. Even more important, take a look at your calculator.
You have that on your What is that, like TI 84 plus N?
Oh, that's
We have software, we have emulator software, so it's,
Download that?
I don't think so.
Laptop?
I don't think so. There was, a few years ago, before it got shut down, there was a guy that did an app for the, for Android. It was called Andy83, and it was a free Texas Instrument calculator, graphing calculator. It did everything a TI-84 did, but faster. It was the same screen, same keystrokes, same everything. It was faster than the 84s.
So how is it fast? So they have to shut them. Aren't these
How do you
They-
make it faster?
The phone, this was 2-3 years ago, the phones have faster, stronger processors than the calculators. The calculators worked just fine, but it was quicker to graph and do all that stuff. It was amazing how fast they were. So he was doing this unlicensed version of a Texas Instruments. Texas Instruments didn't like that, so they shut him down. If you still had the app on your phone, I mean, I don't have that phone anymore, but that app was great. It was a great graphing calculator app. It was so fast. But anyway, look at that. The emulator software.
I was kidding.
The emulator software is for teacher stuff. If you really, really, really want emulator software for your laptop, let me know. I don't think you really need it. But yeah, there's a button here in the upper left-hand corner. It says y equals. And having that button allows you to do so much graphing. Very good, Jack. Brianna Williams.
Oh! Sorry.
It was a mess.
You all right? Yeah, my phone.
That caused everything else to fall out? So the reason why we like slope-intercept form is because there's a y equals button on your calculator. That y equals button on your calculator is going to be your best friend when you guys go to take your standardized tests. It is so important to understand how to put stuff into slope-intercept form. That way you can manipulate, if you have systems of equations, you can find their intercepts. You can use the table function to do all this other stuff. So it's very, very important to be able to know that. Do I still owe you a calculator, or did you just do that? Okay. I was worried because I forgot to give the kid the other earlier today when I was almost out of calculators. So that's why we use this. Yes, sir.
Can I bring my laptop?
Can we bring out your desktops?
Really? Come on.
Leave them in the corner. Hook it up. Fix that.
We done?
Sorry.
Anyway, so we like slope-intercept form for that. And the other one we use quite a bit is point slope. Point slope form does the same idea as slope-intercept does. I know that some teachers prefer to use slope-intercept form for everything. Find your y-intercept and just reuse it. I tend to like to use point slope form a little bit more because you're using, obviously, a point and a slope, and it forces you to solve for y directly into a slope-intercept equation. So the point slope form looked like this. And you probably remember seeing that at some point.
That's the only one I knew how to use, not the other one.
And that's fine. There's nothing wrong with that. Because with point slope, you can easily, so you need an ordered pair and a slope. You can easily distribute and add y over, and it's all of a sudden it's in slope-intercept form. And that's what's so nice about using point slope is that it's 2 steps away from being very, very useful. Another thing is with point slope is that you're going to start to see this, every graph that we do is always going to have some sort of a shift. So it's always going to start with a standard, and then we move it left and right, up and down. Your standard is really your slope-intercept, and then eventually we start moving it from there. You'll start hearing more about that as we go along, when we get to absolute value functions later this chapter. Yeah, especially that. So let's look at an example of point slope.
Oh, okay, so you want the.
What I'd like you to do is take this point and slope and then rewrite it into slope-intercept form. So you start with your point-slope form and basically solve it for y. Okay? You start with your point-slope form and you solve it for y. That will allow you to use your graphing calculator to plot stuff, because we probably won't graph things by hand a lot of times. You'll be able to find intersections, be able to use the table value sets. We can find stuff a lot cleaner. Like I found out from earlier, most people have no issues with this. Biggest mistakes you guys might make with some of this stuff is flip-flopping your x and y value or missing a negative symbol. The algebra part of it is relatively easy for you. So with that point slope, distribute out that -1/2 and solve for y. What did you guys get for your final?
I got it.
What do you got?
Y equals -1/2 plus 4.
Perfect. Alright. So using that point slope form, like you were saying earlier, it's the only one you ever remembered, but it's a good one to remember because it can force you into slope intercept with 2 steps. Okay. Not so scary?
0 squares.
Good. Now, the reason why I use point slope form a lot is because, let's do this one first. What do you do now when you have just 2 points?
No, you're gonna use slope form.
What do you know when you just have 2 points? What can you find?
Slope.
Yeah. Find the slope, and then once you find the slope, what do you use?
Y-intercept.
Then you use point slope.
All right, take a minute. Do this one. Give me an equation in slope intercept form using just given the fact that you know 2 points. Anyway,
Oh, it got me. Wait, what?
find your slope.
You're going to a Cleveland Browns game? That's embarrassing. I'd be embarrassed. Yeah, I'd be
So you got 1 for a slope, right?
Yes.
Okay. Now, does it matter which point you choose to use point slope with?
No.
It doesn't. You should get the exact same result. It makes absolutely no difference. I'm going to use the negative values just to make sure that it's okay to use negatives. So when I say y minus a -1, I just change my signs right away. Instead of writing minus a negative, I'm going to automatically write it as a plus. And then from there, distribute and add, subtract 1. Not so bad.
Not at all.
Very good. So then that leads us into parallel and perpendicular equations.
Well, those are.
All right. So every time I've taught parallel and perpendicular equations, no matter what level it was at, I found a real nice method of showing you guys how to set them up. It may take a second or 2 longer for you guys to go through this process, but what I found is that most students, when they get to advanced algebra, or whatever this class is called now, with Algebra 2 honors, by the time you guys get to this level, your thinking is a lot faster, and you tend to go too quick. All right, you tend to skip a step because you're like, oh, I can just, you just try to get it over with and be done with it. So by doing this method, it tends to force you to slow down for 1 brief second. Yes, sir.
Does this mean that the test is going to be timed like every take home?
I do have a take home every once in a while, but you don't want my take homes.
They're tough. So easy.
Are they worse than says?
Says are pretty bad.
It's
Yeah.
I got a couple good ones.
It was so hard.
Top's
So-
still harder than Sev's.
So here's what I like to do. When you're working with parallel and perpendicular equations, one of the things I always like to, the way I set them up is I ask this question to start with. So if it's a parallel or perpendicular equation. I think so.
Yeah, we can't see your hand on the wrong board.
It's okay. I'm going to write it on both. First thing you want to do when you have a parallel or a perpendicular equation problem you have to write out is you want to identify what's the original slope. So in this problem here, what's my original slope? Yeah, we got to work it backwards. We identify what the original slope is -3. The next step, is it a parallel slope problem or is it a perpendicular slope problem? It's parallel. And the reason why I put this step in is because sometimes students just get so fixated by just doing problems, they forget to read the instructions. Parallel, too. If you are doing a bunch of these problems and they're mixed together, there's parallels and perpendiculars, or if they do 3 parallels in a row and then they switch to 3 perpendiculars, you'll probably accidentally do all of them in parallel. So what this just asks you to do, is it a parallel slope or a perpendicular slope? So, well, if the original slope is -3, what's the parallel slope? -3. Does that make sense by why I'm asking that?
I was gonna ask what ORG
Original. Excuse me, sorry. I didn't explain that. Sorry. ORG stands for original. All right? And now I just use point slope form like we did before. So use your point slope form. So it's y minus 2 is -3, and then x minus 3. And like I said, the only reason why I like to put those steps in there, just so you go back to the original problem to see if it's a parallel or a perpendicular, so you don't go too fast. Because you guys all day long can set up and solve parallel and perpendicular. You can solve and find the slopes without an issue. It's just that you go too fast and not read the question. And this is just slowing you down. All right? I'm going to use point slope. Does that make sense? When you solve this one out, did you get y equals -3x plus 11?
Yes.
Perfect.
Wait, where it was.
Yeah, because all your answers, and all of your answers when you write these equations out, I always want your final answer to be in slope-intercept form. And once again, the reason why I want slope-intercept form is because there's a button on your calculator that says y equals. All right. So when you're all done with this and you move stuff around, okay. And then lastly, I want to briefly define what's called direct variation. You may or may not have seen this before. Direct variation is kind of like a precursor to slope. The reason I decided to bring this back into this section here is that later on in the school year, we talk about stuff that are called, I brought this up earlier, joint variation. 2 things vary jointly. Inverse variation. There's a lot of different variations we look at in chapters. But I just want to give you an idea of what it looks like. It's nothing more than you're given 3 variables and you know 2 of them, solve for the missing 1. And here you're seeing that it's y equals k times x. That value of k is another name for slope. They just don't call it slope. They just don't call it m. They're giving it a y intercept of 0, or y equals mx plus b, where b is 0. So there's no shifting up and down, just your slope is changing on these. So what happens here is that you're going to see the following statement. X and y vary directly. And if that's the case, you know that you will use this. Y equals k times x. The next statement will read y equals 12 when x equals 4, or something along those lines. All right, well, if y is 12 and x is 4, what's k? Not 4,000. You're the first person that did that, though. All right, that's good.
I admire.
What's k equal to? 3. Very good. So 3 is equal to k.
Oh, that makes sense.
You're figuring out you have 3 variables. You know 2 of them. Find the third. Reuse it. Yeah. 15. So then you just use that value here. So y is 3 times 5. You got it. So direct variation is just a little weird of using one piece to solve the next. You're not going to see a ton of it. I just wanted to get you the idea of what it looks like. I've got a couple of problems like that tonight, but it's not too much. Okay. Not so bad?
I heard we have a lot of them.
No, there's not a lot of homework today.
Oh,
15 problems maybe?
yeah, I heard
So.
so much.
I'll put this on double screens while I'm writing this out in case a couple people are just filling that in here. Section 2.2, it's page 81, numbers 55 through 58. And then section 2.4, it's page 95, numbers 25 through 28, 38 through 40, and 43